All right, hello and welcome to this supplemental video for the CS Club at MesaCC. Here we'll be installing a VirtualBox with Arch Linux and some tools to hopefully get us going where we need to go and for the rest of this semester. So I'm in a browser and I got two tabs open, so I'm going to go to this first one and I am going to go to archlinux.com. And here, we'll want two things from here. We're going to want to go to the wiki, because this is where you're going to see where I get all the information from. And we're going to go to installation guide here. So what we want to do is we could go to downloads, and download is also all the way over here. So I'll just open that up in a new tab. And then you could do the stuff up here, but I'm just going to scroll down until we hit the United States. And then with the United States, let's see, just a bit further, the University of Arizona does host Arch Linux ISO, so we could click on that. And then you're just going to want this first one here. So you'll click on that and then you could download it. I happen to already have it downloaded somewhere in my downloads. So you'll want to do that. That takes just a couple of minutes because it is a little big. It's 1.1 gigs. And then the other place you're going to want to go to is you'll want to type in VirtualBox. This is if you're on a Windows computer or one of the older Macs with the Intel CPUs. So this link is currently broken. Oh, never mind, they finally fixed it. So it was broken yesterday. So you could download it from here, or you could also download it from Oracle since they're the ones that actually own it. So yes, this will be for your Intel Macs or any Windows you have. If you do happen to have Linux and you're just doing a VirtualBox, you probably don't want to download it from here. You probably want to download it straight from your package manager and read whatever resources they have. So in particular, I'm doing the Arch Linux. I'm running an Arch-based distro right now, so there's extra packages you have to download that are not just VirtualBox, so make sure you read up on those. But you'll want to download those and then install them as you normally would. If you have one of the new Macs, you'll want to do the M series Mac virtualization. And then I'd go to this one, and that screen won't pop up for you normally. So you want to jump all the way down to here. So there's multiple options. Some of these are paid for, as you can see here. I've heard that this VMware Fusion is good and it's free for personal use. And I've also heard that UTM is also good. So either of these will run on the M series Mac or the Apple Silicon. So if you have one of the newer ones, the M1, M2, or M3, you'll want to use these ones. And I think they're both free when you are doing it for personal use. So you'll want to check those out, and you'll want to read any additional documentation on them. But I'll be showing this in VirtualBox because I think most people will be running either an older Mac or Windows. So once you have the installation done, you're going to want to open up VirtualBox. So this is kind of what it looks like when you first open it up, except you won't have these extras on the side. So you'll want to find this new button or anywhere where it says new on yours, and you're going to hit new, and you want to give it a meaningful name. So I'm just going to call it Arch CS Club. It's good to name things either camel case or snake case or anything like that, so it's not normally good to put spaces in names. You want to pick where you're going to put this download. So one thing I recommend is if you don't have a whole bunch of hard drive space to play around with, you could get a flash drive and put your installation there, but I have enough, so I'm not going to do that. And then here is where you're going to want to find that ISO you just downloaded from the Arch download page. So I'm going to hit Other, and I believe it is in here under ISO. So you just want to double click on that and make sure that the extension is an ISO at the end. So that's your image file for this download. This is basically the operating system that we could play within, and then we'll download it to the machine. So if you're somebody who's downloaded Windows in the past and you had to download it with the CD, we're doing the same exact thing here. So when we named this Arch, VirtualBox here auto-detected that this was a Linux operating system, and specifically it's an Arch Linux. I don't know if this actually matters or not, but maybe it does some configuration internally. But if these didn't auto-populate, just make sure that you switch it to Linux, and then you'll find Arch Linux. It's probably towards the top. And you want to make sure it's a 64-bit, because that's the ISO we downloaded was the x86 64. Arch doesn't run on any other CPU type unless you find a community edition that's not officially supported. So this part is completely up to you. It's how much of our computer's personal memory and CPU power are we going to put towards this VirtualBox. So just because I'm doing a demonstration, I'm going to kind of make everything large so that it goes by a little quicker. But as long as you're sticking within your green zones, you should be good. You do want to make sure you have at least 4 gigs of RAM that you could put on, and you do want to make sure you have at least 2 processor cores or threads, whatever you want to call them here. But I am going to do, let me get out a calculator real quick. I am going to do 16 gigs of RAM on this, which is 16 times 1024. So that's going to be 16,384 megabytes of RAM. This is completely overkill for this VirtualBox. I just kind of want the demonstration to go by kind of quickly, so we're not waiting on certain stuff to finish. And then I'm going to go up to 6 cores for my physical CPU. But again, as long as you're sticking to the green ranges on yours, you should be good. If we go to the official Arch Wiki, we can maybe see right here. So Arch Linux should run on any x86 64. That's why we have a VirtualBox in case you have an M series. But we have a VirtualBox so you could just play around. But this is the type of CPU that Arch runs on, compatible machine with a minimum of 512 megabytes of RAM, so that's half a gigabyte. Though more memory is needed to boot into the live system, so I'm going to click on this to show you what you need minimally. So let's see. It doesn't look like this person gave a recommendation, but I would recommend you do at least 4 just for future stuff we do in the class. If you don't have that much, try to do 2. It shouldn't be too affecting, but sometimes when you're downloading stuff, you want more RAM. And if you have a lot of storage space but not a lot of RAM, we could also get around that too. I'll show you that later. But just try as a minimum to do at least 2, but probably you want to do 4 gigs of RAM. So you want to take 1024 times however many gigs you want your RAM to be. And then basis installation should take less than 2 gigabytes of disk space. So I'm going to be giving it a lot of space, which you'll see later, just because I'm going to be downloading a lot of stuff, and I want you to have the option to download a lot of stuff. So we'll show that later. But I'm going to hit next here. So Just to recap, I'm doing 16 gigs with 6 CPU threads because I have 16 to spare. So this part, you probably do not want to do 8 gigs. That's probably going to be way too small. Now this might be overkill, but I'm going to do 50 gigabytes for this VirtualBox, just so I can experiment with downloading a lot of different software and play around with it. I believe in the past I've gotten everything around 20 gigs. That's like absolutely essential for playing around with a lot of different programming languages and some IDEs, but 50 I'm fine with doing because I have 2 terabytes to play around with. You can change this later on. You can make it smaller, you can make it bigger, you could migrate it to a thumb drive later. But 50 I think is going to be way overkill. That's why I'll do it, just to play it safe. And then you just want to make sure everything's good on here. One thing, if you are semi-knowledgeable about your motherboard, is you do not want to click this enable EFI. That will kind of break this later on. So do not do EFI if you are familiar with UEFI and stuff like that. So we'll hit finish, and then it's just getting ready. So as that's, it technically is finished, but I want to show you kind of where we're going to go with this. So this is what I've played around with before, and we'll just wait for it to boot up. Since it is in a VirtualBox, it takes a little bit longer to make everything go, but I'm going to type in my username and password. Let's see. Okay, so we're in a terminal. This is obviously boring and probably not what you want to be in. So I've downloaded a GUI for us to play in, and then when I launch a terminal, it goes full screen. Let's see. So to show you what we've already done, right now we're running on only slightly less than half a gigabyte of RAM. So like I said before, if you can't do 16, that's more than fine because we're already running on less than half. Let me rerun that command just to see if it updated at all. Oh, it went down further. If you were at my operating system talk, you saw that I was running on about 3.5 gigs of RAM when I was doing a whole bunch of stuff. So yeah, you do not need to go overboard. You can do 4 gigs of RAM if you want to do that. So we've got a terminal, it looks nice, and we've got this window manager that will spawn new windows and tile for us automatically, so that's kind of nice. And then I'll show you the other stuff when we're done. So I am going to full screen your VirtualBox. You have to do the right control key, so not the one next to like your Windows key or the command key, but the one that's closer to your arrow keys, and then F. That full screens your VirtualBox. I'm just going to close this, and then for whatever reason, if you're downloading stuff and you're like, man, I need to leave or I need to power off, do the save state machine, because that will save the current state of your VirtualBox. But if you are fine with just downloading or turning it off, you could do power off. So we are going to boot into this one we just made. And as you can see, it's a little bit more fancier because the Arch people have made kind of just a nicer experience right out of the box. And this is like if you put in the Windows CD to install it for the first time, this is kind of what's going on right now. But so like Windows and Macs and some of the easier Linux distros, you know that there's either a GUI or an install wizard or whatever you want to call it. That's not how Arch works. It's never really worked that way. There used to be an install script that kind of did it for you. But we're going to be doing it all manually so you can kind of appreciate what goes on when you install an OS for the first time. So if we were doing this on physical hardware, there's a bunch of instructions right at the beginning that says if we need Wi-Fi, we could use the IWCTL tool, or we could do the NMCLI. So NM is Network Manager. It tells you to follow the installation guide, which, remember, I have that on another page. And then we can actually boot up into the install guide from this ISO if we were doing it on physical hardware, but I'm just going to switch back and forth. So we are auto logged in as the root user. So if you're familiar with Windows, that's kind of the same as an admin. We could really do whatever as root, so we don't want to be there for too long. But since we're doing installation, we need to be root the entire time. So let's see what the very first thing we need to do is. So I'm going to go back. So we've already acquired the install image. Normally you do want to verify stuff for security concerns, but since I just did this the other day, I'm not going to worry about all of this stuff. If we were doing this on physical hardware, there's a step that shows you how to download that ISO onto a USB. It's not as simple as just dragging and dropping. You have to burn it onto the USB flash drive, so there's extra steps for that. So we just boot into the live environment. Again, if we were on physical hardware, what we would want to do is hit like the F12 key or the delete key as our computer's turning on, so we could boot into the BIOS and then select the ISO. When we did, I'll show you right here in the settings, we technically have done that right here with the storage. So this right here is the same thing as if we hit F12 or delete to get into our BIOS. That's what we're doing right here. Let's see. Okay, we did that. If you're using a different keyboard, so like a foreign keyboard, you'll want to follow these instructions here, but it defaults to a US keyboard, so I don't need to worry about that. One thing I'm going to do, just to make it a little bit easier on all of you, is that I'm going to change the terminal size. So one thing is normally copy and paste doesn't work between your physical machine and VirtualBox. You have to select some settings for that. But I believe it's nice to hand type out all these commands from the beginning. So we got set font ter-132b. I'm not going to be using 132 because that's a little too big for this small area, but we will do so. If it's not typing, you just have to click somewhere in the box. And then I'm going to do 122b, and that's just going to make the font size a little bit bigger, so hopefully that's nice for everybody. So one of the first things we want to do is check whether we have a UEFI board or if we have a BIOS board. So if you were installing this on physical hardware, this is an extremely important step. It's technically important no matter what, but what that basically does is tells the ISO that we need to partition our disk in a certain way. So if I go here, we have this long command to verify the boot mode, which is cat and this file. So let's read this real quick. If when we run this command we get a result of 64 back, then we're running a 64-bit UEFI. If we get a 32 back, then there's 32-bit UEFI, which this is not technically supported by Arch, but there's some workarounds. And then if we do not get anything, then we're in BIOS mode. So let's do that real quick. So instead of full screening and exiting a whole bunch, I'm just going to kind of keep it in this mode. And actually what I'll do is let me put this over on the other page so that we could kind of read the instructions while we're here. And let me see if I can minimize this. No, I can't right now, but that's fine. So let's go back here. So let's run this cat, and when you're on the terminal, if you type enough of the path that the computer can recognize it, you could actually just hit the tab key to autocomplete. So if I type in FIR, I could hit the tab key and it will complete firmware. And then I'm going to do EFI. So right here, we could already tell that this file is not going to exist, but I'll just finish typing it so you could see. Oops, size. So I'll make sure I typed it all correctly. And then I'll hit enter, and then there's no such file or directory. And then another thing is if I full screen this, you can see there's a little frowny face over here. That's because that's what happens when a command or a file doesn't exist. So that means we're in BIOS mode, which you can see right here. That will be important later on, so just keep that in the back of your head. One nice thing about VirtualBox is that we don't have to set up the internet because it's just going to do whatever your internet is currently on your main machine. If you are installing this on physical hardware, I 100% recommend to do it Ethernet-wise. Now, the first 3 years I ran Linux, I had to do it via Wi-Fi, and it's kind of just confusing if you haven't figured out how to do it because the instructions aren't super clear. I do think they've streamlined the instructions a lot, but they also have taken some stuff out of the instructions. So just try to do it via Ethernet if you're doing it on physical hardware. But if not, there are, again, workarounds. And we don't have to configure anything, so we want to verify that we do have a connection by running this command. So it's the ping command, archlinux.org, and this is working. So if you're seeing the 64 bytes from blah 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 blah, that means the ping command is working. Now this is going to run forever, so if I try hitting enter, nothing's going to happen. It's just going to keep running that command. So what we have to do is terminate this command, and how we do that normally is by hitting Control-C, and that will quit the command. Sometimes it is Control-D. That does kind of the same thing. It just depends on what the program considers the kill key to kill the process. So next we're going to want to update the system clock. So that's time date CTL. And I don't think the time is right. No, the time is not correct, but we're going to synchronize the time at a later date. Remember how I said this is like putting the CD into your computer? Right now we're just on the CD. We're not inside our machine yet. And we'll do that at a later date, but our ultimate goal is to take that ISO off of our computer. So take the disk out of the disk tray and then run the computer without the disk so that it's on our hard drive. So I'm not going to worry about the time date right now because it's not really useful. But it is nice to verify that this is at least the correct date today. It is September 14th, 2024 as of this recording. Okay, so the next is partitioning the disk. Now there's, you could really get into the weeds of how you partition a disk, how you format disk and all of that stuff. So if you were in the talk, we talked about Windows has NTFS, Apple has their own proprietary file system, so on and so forth, which is this command. It's going to be this one and then the next one formatting. So there's a whole bunch you can do on this part. I'm just going to go the simplest route. So what we want to do is to format disk, we need to look for either a /dev//SDA or an NVMe. So SDA is hard drives, SSDs, or thumb drives. NVMEs, those are the ones that looks like a stick of gum that you put into your computer, but these are all storage devices, and we could figure out what we have by running either lsblk or fdisk-l. So I'll just show both of those right now. So here we could see that we have a loop 0, an SDA, and an SR0. loop 0, which it says right here is something that we could ignore. SR0 we're also going to ignore. That's normally something like a CD drive. It can be other stuff too, but we could ignore both of those. But what we're really looking for is that SDA, and we could see it's the 50 gigs that I told VirtualBox to give this machine. So that's kind of cool. SR0 in this case, I believe, is acting as the internal thumb drive or the CD drive. That's why it's 1.1 gigs. Remember, that's the size of our ISO, so it's cool that it's recognizing all of that stuff right off the bat. I'll also show you what fdisk does, so fdisk-l. So this gives you more information on what kind of model hard drive or SSD or whatever you have. And then let me show you it on my physical computer too. I have to go up here. So LSBLK on mine. So I have 2 NVMe drives. I got this first one and then I got the second one. And you can see it has the mount point. So we'll be talking about that very soon. If you want to run fdisk while you're in Linux, you actually have to do it as a admin or a privileged user. So I have to run sudo fdisk-l, put in my password, and you can see these are WD black NVMEs, and it tells you what kind of file systems we have. We have the EFI. This is if I was running a UEFI, which my computer does. We're not going to do this one, but we are going to do a Linux swap and a Linux file system. Cool. So we've identified what drive we have. We have that, if you see right below the fdisk command, it says disk/dev/SDA. That's the one we're going to want to do. So I'm going to scroll down and it says to run this command. So /dev/the disk to be partitioned. So notice how this is in italics. Anytime you see italics on the Arch Wiki, that means you have to substitute the command for something on your computer. You don't write that actual thing. So we're going to do fdisk/dev/SDA. So it says welcome to the fdisk utility. Cool. We're going to run through this real quick. So take a look at this note. Take time and plan a long-term partitioning scheme to avoid risky and complicated conversions or repartitioning procedures in the future. So yes, it is dangerous to repartition your system. You could completely wipe out everything on your drive. You could overwrite stuff. You could just corrupt stuff. But if you follow what I'm doing, and we'll all be the same, nothing should go wrong. But if you're doing this on physical drives, this is something you want to plan out long term. And then there's other notes here. I'm skipping a lot of the explanation on this stuff because you could read that on your own. And when we're doing it in VirtualBox, a lot of this stuff doesn't matter, but it is important to read everything on this page at your own time. So a swap file, just before I get there, swap is taking your hard drive or NVMe or whatever, your SSD, and turning it into RAM. So we'll be doing that because it's always recommended to do a little bit of it, normally 4 gigs, which is what we'll do. But there's an algorithm that they have somewhere on this page to calculate further stuff. So if you were doing UEFI, you would want to do a GPT scheme with these as a bare minimum, and you could change them later. But remember, we're not doing UEFI because that command we ran at the beginning didn't give us anything. So we are running BIOS, so we want an MBR. So if you look here, it says welcome to fdisk. We'll skip that first paragraph. The second one says device does not contain a recognized partition table. Created a new DOS, which is MBR disk label. So we're good. We don't have to change anything there. Anytime you're running a new command in Linux, you always want to do the help page, which normally is not M. That's just the case for fdisk. But if we do that, we could see all the commands. So at this point, I am going to full screen so we could see everything. Excuse me. So if we were running UEFI, we would want to choose this G option to create a GPT table. But we are already running the MBR type partition table. So right here, we could see that N is add a new partition. So I'm going to do that. Actually, before we do that, let's do P to print our partition table. So here is just information about our hard drive, which is the SDA drive. And as you can see, there's no partitions yet. So I'm going to hit N. Excuse me again. And we want to choose primary every time, unless you're doing something special. Then you will want to use E. Partition number, we'll do the default. First sector, you always want to just choose the default unless you really know what you're doing. And then the last sector, so right now we're going to make swap space, which means we're going to take part of that 50 gigs and turn it into RAM. The reason we need to do this is because if your computer hibernates at all, it could corrupt like the current files you're working on. So you do want some swap space, but you don't need to do a whole lot. So what we're going to do 4 gigs is we're going to do the plus sign, which is what it's telling us right there. And then we want to do the number 4, and then we're going to hit capital G for 4. So add 4 gigs onto this partition, and then we're going to hit enter. Notice that it created a new partition of type Linux and size 4 gigs. We do not want Linux as this file type. We want it as Linux swap. So how do we change that? Well, we could hit M again. And then right here, you can see that T is change partition type. So I'm going to do that. I don't happen to know what Linux swap type is, so I'm going to do capital L to list all the types. So notice up here, 82 is Linux swap. There's also an alias that if we just type in swap, it's going to do the same thing for 82. And our type just got switched to Linux swap. So if I print the table again, you can see we now have a partition SDA1, which is of type Linux swap. So I'm going to do new again because I want to use the rest of the space. Right now, if we just wrote this, we'd only have that swap space and we wouldn't have access to the rest of the hard drive. So I'm going to do P again, select the default, and then if you wanted to do more partitions, so like let's say you wanted different users to have different hard drive space or anything like that, you could do that. But I'm just going to hit enter to use the rest of the drive. So we could see a new partition type 2 of type Linux has been made with a size of 46 gigs. So I'm going to print that partition table again. Now you can see SDA2 has been created. It's 46 gigs and it's of type Linux. So how do we write this? Well, to save and exit, we write it, which is W. And notice we're back into the command, the prompt as the root user. So great. So we've just partitioned our disk. Remember, you really want to spend time doing researching it if you're doing it on physical hardware. So, and that was the only scheme for BIOS. This is the simplest one you could do. One thing I do want to talk about if you're a Windows user is that you are probably used to your disk being like a C drive or a D drive or any letter drive. That's the exact opposite the way that Linux does stuff. So in Windows, you always have a C drive, and that has the vast majority of your applications on it. And then if you add a new drive, you just name that drive, and then you use that drive as something that's completely separate from the C drive. In Linux, however, I wonder if I could find the Linux tree. Let's try Let's try just partitions and see if that will come up. Or I'll just do, let me full screen this so you can see it. Let's go to the Linux file tree. Let's see if there's an image or something like that. Okay, so in Linux, what you have is you have a virtual file tree. So the root is the like root of the tree, as you could probably imagine. And then there's these subdirectories, which you could read about them here. But what you do in Linux when you add a new drive is that you attach that drive to a folder. So old drives are underneath the file tree. It's just where is that drive located. So some people like to have a separate drive for their home drive because that's where their like personal files live. Some people like a different drive for their opt and user drives because that's where software lives. But it's kind of all up to you. But just know that if you're used to the Windows way of doing things, having a drive and having folders under that drive, that's the exact opposite philosophy of Linux, where there's a virtual file tree that the Linux kernel knows about, and then you attach hard drives somewhere into that tree. So kind of interesting and a little different. So let me see. Let's go on to the next part. So we just partitioned. And you can choose on this next part, you could do a little different stuff. So when we format, that's like the NTFS for Windows or the proprietary Apple file system, the APL or AFS, sorry. Here in Linux, the most common one for your hard drive, so not the swap space, is called ext4 or extension 4. So I'm just going to copy this as is and do make fs ext4 dev and then our root partition. So remember when, so actually before I run that command, I'm going to do an lsblk again. And notice how our SDA changed. There's now two things under it, SDA1 and SDA2. Our root partition is going to be that 46 gig one, which is SDA2. So remember, SDA is a hard drive and SDA2 is a partition of that hard drive. So I'm going to do that make fs.ext4 dev SDA1, or excuse me, not 1, 2. And we're going to run that command, and it's going to go really quick because 46 gigs is not a whole bunch to run that command on. And then if we created a swap partition, which we did, we want to run this command. So make swap dev SDA1, because that was our 4 gigs. Cool. Now, ext4 is not the only partition type that you could do. It's just the one that's kind of the average. What are the benefits of other ones? Some of them are faster. Some of them have backups kind of pre-built into them. There's a lot of different ones. So if I type in mkfs and then space, or excuse me, tab, you could see all the different options we have. So there's the bcachefs, BFS. That third one is normally called butterfs, but it stands for btreefs, which is a data structure type for like the binary trees. Some of you may be familiar with VFAT, which is that second to last one. VFAT is normally what your thumb drive is. So if you've ever heard of FAT32, that's what a VFAT is. So all different stuff. If we were running UEFI, then we would have to create a third partition, which I'll show you right here, that is mounted onto the boot folder, and you have to make it, oh, it doesn't actually tell you right here. Let's see if it tells you down here. Yeah, if we have a UEFI system, then we have to format it as a FAT32 because that's what UEFI recognizes. So we've just partitioned and done all that. So let me see if this works. If you look under SDA, you can see that we have SWAT space and we have the ext4 partition type. So we're good to go. We can move on to mounting these file systems. So far we've only interacted with like the CD in our computer or the thumb drive mounted to our computer. We actually haven't touched our computer yet. So we have not actually done anything with that 50 gigs. We haven't installed anything or done anything to it yet. So how do we do that? Well, that's this next step. So we're going to mount the file system onto that virtual tree, onto the root of the actual computer that VirtualBox is made for us. So what we have to do is type this command. So mount /dev / okay, root partition is in italics, so I'm going to do that SDA2 because that's our root partition. And then I have to do that onto mount. So I'm going to hit enter. So now if I run lsblk, you could see that SDA2 now has that /mount at the end. That means we've now attached that partition onto the file tree. Before, it was kind of just like in limbo. It wasn't attached to anything, so we couldn't do anything with it other than format it, but we couldn't store anything onto that drive yet. Another thing we want to do is do this command because we made a swap partition, so I'm going to type swap on /dev /SDA1 because that was our 4 gigabit partition. And then this will be a later step. Okay, so this is the part where on doing real hardware, you really want to take the time to do a lot of research ahead of time, because now we're going to install the operating system and some tools onto the actual computer that VirtualBox is made. So again, going with the Windows analogy, you've popped the CD into the CD drive. You've now partitioned the hard drive, but now Windows has to be installed onto that hard drive. So now we're installing Linux onto the hard drive of this VirtualBox. So this used to be harder a few years ago, but the devs for Arch Linux have made it significantly easier because they've added that the fastest mirror already shows up to the top. So if you didn't know, when you download software, it doesn't just download from one place in the world. Depending on where you're at, it changes where it's downloaded so that you get the fastest download speeds. That used to not be the case for Arch. You used to have to manually go in and set all of those mirrors yourself. Now it's a bit better because the auto do it for you, so that the fastest one is first and the slowest one is last. So this is how you would do it before. We're going to skip that part. So now we're going to install the essential packages, and this is kind of wrong. If you just wanted a terminal and like the shell bash programming environment, you would just download this. However, we're going to want to do like way more than that because we want to program on this. We want to do Arduino stuff on this. We want to do a whole bunch with this. We also don't want to just live in the terminal. We want a GUI environment so that we could do web browsing, so we could do web development and all of that stuff. So I am going to follow this and only add a few more packages to the front or to the end of it. But note that if you followed this as is, you would not really be able to do a whole bunch with your computer. So one thing that before I get onto this, is the philosophy of downloading software between Windows, Mac, and Linux. So in Windows and Mac, as we did on this page, the page before, is that you would go to the software's website and then you'd click on a link and download that software that way. You do not do that in Linux, or like you would use an app store, which some Linuxes do have an app store, but not Arch. So on Arch, or on most Linuxes, which you could actually do it on any Linux, some just have an app store on top, you do what's called a package manager. So any software you could download that you don't have to compile yourself is located on a server, and you use Linux tools to download that for you. So just as an example, Linus Tech Tips downloaded Linux for a challenge, and he was downloading the NVIDIA drivers directly from the NVIDIA website. You would never do that on Linux unless you knew exactly what you were doing and you knew how to configure everything yourself. You want to download the NVIDIA drivers directly from the Arch Linux servers, because the Arch Linux devs have already figured out what needs to be configured to make it work on their OS. So here we're going to download base, which this is like your shell, your bash shell and all of that stuff. Some of your utilities like copy and paste and move. Linux is the actual kernel, which you don't have to download the Linux kernel from like Linus Torvalds. There are other Linux kernels, so some of them are better for gaming, some of them are better for audio. There's a whole plethora of different kernels that you could choose from, but we're just going to go with Linux. And then if you saw my video on the operating systems, you would know that I said that it's almost impossible to have completely free software on your computer, free as in freedom. So if you had an Intel, say, Wi-Fi card, you have to download closed-sourced binaries, which are called blobs in the Linux world. And that's what this firmware stuff is it's that proprietary software that you need to actually run your computer. So I'm going to run this command, pacstrap-k/mnt. So pacman is Arch Linux's package manager. We'll get very familiar with that later in this video. But pacstrap, what that does is it installs the software somewhere else than the current machine you're running. So remember, we're running on the CD right now. We want this to install into our actual computer's hard drive. And when I say actual computer, I'm talking about the VirtualBox computer, not like your physical laptop or desktop computer. And remember, we mounted the actual OS onto the mount file tree. So that's what that first part of the command does. And then we're going to run base Linux firmware. And then the only thing I want to add on right now is these manuals, which are called man pages. So I'm going to do man db and man pages and tech info. And then remember how I said this would almost be useless? They don't actually include any sort of text editor. So if you're used to Windows, there's no notepad when you download just this. If you're used to Mac, there's no text strangler. I am going to download something called NeoVim. If you've never used NeoVim before, it's kind of a hassle, but I'll walk you through how to use it in this video. If you don't want to have a steep learning curve, you want to do something called Nano. So this is up to you. Nothing will change for the rest of the semester if you choose either or. I just personally like NeoVim better because once you learn how to use NeoVim, you could be an extremely fast developer. So that's why I like it. And then I don't remember if I had to install this or not, but one thing that's nice to install is NetworkManager, which I know that just went off screen, so let me full screen it. So NetworkManager, all one word. This is how you would get internet working, because the base install of Linux does not connect you to the internet. And then if you were running Wi-Fi, you would want to do WPA supplicant as well. But remember, VirtualBox kind of sets that stuff up for us. So even if you are running Wi-Fi on your physical computer, as long as your physical computer can connect to the internet, then you don't have to do Wi-Fi in the VirtualBox. So I think this is all I want to download for now, and then we'll add more stuff when we're inside the VirtualBox computer. So I am going to just double check I spelled everything correctly and then hit enter. So this is going to take a while. This is I can't scroll up because I'm in the ISO, but you could see that we're going to download about 1.25 gig of RAM of materials onto this computer. So we're going to let this run. As you can see, there's 171 packages that we're installing. So a lot of those are from base and a lot of those are from neofetch. But and the Linux kernel is very big, and so is the firmware. So almost everything we downloaded has a lot of components, but we won't have to update those later, so that's good. So I'll let it go through this. It's almost done because it's very fast. It's just checking to make sure everything's good and everything installed correctly. Since this is the first time we're doing this, it's going to take a lot longer than normal. As you probably know, if you've ever installed Windows or installed Mac OS onto hardware, like as if it wasn't already pre-installed, you know that this takes a while because it's downloading literally an entire operating system onto it. But as you could see, the system itself, it only took about 25 seconds to do that. And then this user part, that's just to display all the text on the screen. So it took about 11 seconds more just because I was printing everything to the screen. So you could see Linux is pretty fast. It only took 25 seconds. You know, if you've ever done it with Windows, that usually takes like 5 to 10 minutes to download the entire Windows onto something. So pretty cool. If you did less cores, this would probably be a higher percentage and it would have taken longer, but remember I gave this 6 cores. Okay, so do read this to make sure you have everything that you want, especially if you're doing it on physical hardware. So if you have an AMD CPU, you want to do this. If you have an Intel CPU, you want to do this, so on and so forth. So now we're going to configure our system. So if we ended right here, we wouldn't even be able to boot into the OS because we don't even have a bootloader. But we actually need to tell that bootloader where to find all this material, and we do that with this fstab. So I call it fstab. It actually stands for file system table. So we want to generate the file system table. This -u is to get the UUID of your hard drive. So let me show you that with LSBLK. So SDA1 and SDA2 are labels that are on our partitions, but those labels could change in the future. And if those changed and we didn't do this -u option, we would break our entire computer. So I think if I do fdisk-l, you can not fdisk, so it must be lsblk-f. These right here, so above the 2024, so these, not the last line, but the second, the two second to last ones, those are the universal identifications for these partitions. So we're going to do the gen f stab-u mount. So what this is saying is that we're going to take these UUIDs and paste them into our new computer's hard drive with the UUID. So that way when we have a bootloader that actually boots us into the operating system, we're always going to use these unique identifiers so that if for some reason these labels change, the SDA1 and SDA2, these UUIDs would never change. And the reason we're doing mount is because, remember, mount is where our actual computer is right now. Currently we're on the CD. So we're gonna, when you see two greater than arrows, that means we're gonna take the output by this command, everything in front of the greater than symbols, and we're going to paste it into the thing on the other side. So this is doing it into, this is like, mount is like the root of our new computer. Etc is where configuration files go, and then there's a file called fstab. So we just want to paste it there. If you don't see output on Linux, that's normally a good thing, because normally you're just getting errors with outputs. So everything went well there. So now this next part, the che root, what we're going to do here is actually go into our new computer. So I'm going to run this command, arch che root, and remember you could use the tab key to autocomplete. And I want to go into my new computer at the root of it, which is mount in this case. Okay, notice how our prompt just changed. There's the red root above and the normal root, the white root below. That's how you know we're inside of our computer. So if I type pwd, which is print working directory, we are now in the root directory of our actual VirtualBox computer, which is kind of cool. So we want to set the time now. So remember I said if it wasn't working before, it's going to work now. So what we're going to do is we're going to link with a symbolic link. So that's kind of an advanced thing, but it has to do with your hard drive. We're going to link, let me start typing this in. The user share zone info. Region is we are in America, and the city we're in is luckily Phoenix, so luckily we could just skip right to that. If you were doing it for somewhere else, what you would want to do is when you're on this part, you want to hit the tab key twice, and you could see all the different mainly countries that you could choose from. So again, we're in America, and then you could hit tab twice again. And because there's a lot of output, you want to hit yes, and I'll full screen it real quick. These are all the different cities where a time zone is normally associated. So you won't find any like Mountain Standard Time or anything like that in here. You'll just find cities, so like New York, Los Angeles, and all of that stuff. But we have Phoenix. And I need to close out of this, and we want to link that to, so I put a space here, etc.local time, and just hit enter. So we just linked the time zone to our actual computer, and then we want to update the time zone for our CPU right now with HW clock syst to HC. So now the actual time is on our like VirtualBox CPU. So that's kind of nice. I'm gonna skip this other stuff. Okay, localization. This is to figure out what character set we need. So if you downloaded NeoVim along with me, you're going to want to type nvim, and then we're going to go to this file right here, etc localgen. If you downloaded nano, you'll want to do nano here instead, typed just as is, but I did not have a nano, so nano is not on my system at all. Okay, so if you're in nano, you just want to use your regular arrow keys and go all the way down to where it says en, so English _US UTF-8. In NeoVim, we could get there a little quicker, so I'm going to type the / key and then do en _US. I'm going to hit enter. Then I'm going to use one of two things. You could use the H key to move left, or you could use the left arrow key, but make sure your cursor is on the octothorpe or the hashtag or the £, whatever you want to call it. And then you're going to hit the letter X to uncomment that line. So these are all comments right now. And then you're going to hit the colon key, which is the double dots next to L, and I believe you have to do shift that key. So let me check it. Yep, and you'll see that the colon just came up right here, and then we're going to type in WQ, not WD, and hit enter. So that just saved the file. For some reason in the Arch ISO / like when we're downloading stuff, you have to hit enter a few times to clear the screen. You could also just type in clear to clear the whole terminal. If you were in nano, it should have a prompt at the bottom, but if you do Control X, I believe that saves it, but you could read the nano page right below. It should be on screen how you save everything. So we just saved that. We just edited this page, so now we want to type in localgen. This is a command that tells our computer to use that English United States UTF-8 system. If you want to type with other character sets, just make sure to go here again and uncomment the ones you want. So if you want Spanish, I believe that is ES. So I believe that's the Spanish character set. And then if you want like Japanese, that's the JA character set. Always go for the UTF-8 unless you know you're supposed to do something different, and then just save and quit. So now we want to go to this file. So we want to create the locale conf. So I'm going to do that. To create a file, you could either do touch, which creates a new file, or you could run your editor. So nvim etc locale.conf. Make sure you spell it correctly, because then the computer won't recognize this file. Notice how there's nothing here. Now, NeoVim is what's called a modal editor. So if I just start typing L, you'll see that nothing happens. And then I could do A and all that stuff, and A will actually do something different. So to actually type in NeoVim, you first have to hit lowercase I. You can see we're in insert mode now, down there in green. So I'm going to do capital LANG equals en _us dot UTF-8. If you did other locales, I don't think you want to add them here. I think you want to add them somewhere else, but just do whatever your main one is for now. So mine is English, and I'm going to now notice how I just had a colon there. I didn't want to do that. you want to use your escape key to get outside of insert mode. So now you can see we're in what's called normal mode right now. So that means we could run a whole bunch of commands. So if I wanted to delete this whole line, I would do dd. Then I could paste it back. You could do a whole bunch of crazy things. You could do O to start a new line. You could do capital O to do a new line above, so on and so forth. But this isn't a NeoVim tutorial. We'll do that. We could do that later. So I'm going to do :WQ. Remember, you have to be in insert mode you have to be in command mode to type this. So if you see the word insert right here and you're wondering why nothing's happening and you're just typing, that's because you have to hit escape and then :WQ to write and quit. Then I'm going to type clear to clear the page. We don't need to mess with this part. So now we're going to do this network configuration. This is important when you want to set up server stuff on your computer. But I've never really ran into the issue of not having to do this, but it is good to get practice doing everything the Arch Wiki says. So to create a file, remember, type in your editor name right here, and then etc host name, hit enter. We need to type stuff, so I'm going to do I, and you just want to name, so this is kind of like naming your PC or your computer. So I'm going to call it Arch capital CS for Arch Computer Science Club. I'm going to hit exit and then :WQ. You could name it whatever you want. Just make sure that it's not super long and crazy, because then it's going to be hard to remember. So now one thing they don't do anymore that I think is important to do is we want to click on this. This used to be in the actual Arch Wiki installation guide, but now they've put it in a separate spot. So I'm just going to go down to where I can find the table that I need. And if I can't find it soon, I'll just type in, I'll just Control F it. Okay, set the host name. So this is what we just did. This is an alternative way to do it. It must not be on here. So I'm going to go to the top of the page. So I actually have NeoVim commands built into my browser. So GG is the way to go up to the top of a page. I'm going to do Control F and I'm going to type in hosts. Okay, here we go. Let's see. Let me see if it's somewhere else here. Here we go. Okay. What we want to do is we want to make this file right here. So I'm going to do nvim /etc/host with an S at the end, hit enter. I hit O right there, so let me actually do that again. So remember, this is called normal mode, so all I could do is move around. I can't type anything, but if I hit lowercase o, it's going to start a new line for me, and I want to make sure it's not commenting the line. So I'm going to do I'm just going to type everything as is here, 127.0.0.1. Hit the tab key, localhost. Basically the same thing except : :1, and then I'll hit 2 tabs, localhost, and then 127.1 or 0.1.1, and then your host name is in italics here, so I'm going to put Arch CS because that's our local host name. These are just nice to do in case we do anything with networking. So gotta hit the exit key or escape key, and then I'm gonna write and quit. Now I'm gonna go back to the Arch Wiki. So we just completed networking. We're not going to do this because it's not important. We do need to set a root password. So what you're going to do is type in so I'm going to do clear. Do PASSWD, so that's basically password change. And then hit enter. And then type in whatever long and complicated password you want. Then you're going to have to retype it. In Linux, they do not show any asterisks or anything. It's just a blank thing. So just make sure you typed it correctly both times. It will tell you if you made a mistake. But you can make the password whatever you want. It could be 1234. It could be password. Just make sure you remember it because it's basically impossible to recover that password as the administrator. Next, we're going to do a bootloader. So I'm going to click on this. Now, the reason they have this as a separate page is because you could choose any one of these bootloaders, but the default one is almost always grub. So I'm going to go to grub. We don't need to worry about this. Remember, we do not have a UEFI system. So if you go to this little thing, and let me full screen it so you could see. So if you have too small of a screen, you have to hit that little hamburger menu, but we have a BIOS system. So I'm going to go down to BIOS system, which is part 3. I'm going to scroll down to installation. So the first thing we need to do before we even get to that installation, which is at the very top of the page, is we need to download grub. So first install the grub package and EFI boot manager. I don't think we need EFI boot manager for BIOS system. Install the grub package. So we do not need EFI boot manager. So let me unfull screen this. So how do we install software on Arch Linux? We do not use pacstrap again. We use what's called pacman. And we are going to do the dash capital S lowercase y u. Now, to download stuff, you just need this command, but it's always safe to do capital SYU because that's going to update your full system, and normally you do want to be doing that. So I'm going to type in grub. Remember, we're on our actual computer now inside VirtualBox, so I'm going to hit enter. As you can see, it's 33 megabytes. Download it. We're done. When you download stuff from the terminal, it's usually lightning fast. And then we want to run this command right here, which is grub install --target equals. Now, even if you don't have an i386 PC, which you probably don't, you probably have an x86 64. And remember, that's the type of ISO we downloaded, is the x86 64, so the x86 architecture. Even if you have something else that's not an i386, you want to type this command as is for historical reasons. PC space /dev/. So we want to do it on our disk, not our partition. So that's SDA. Remember, SDA is the name of the disk, and then it had 2 partitions, 1 and 2. We're not going to do 1 or 2 here. We're just going to do the disk because that's the way grub works for BIOS type system. So we're gonna hit enter. Oh, I spelled target wrong. Target. Okay, no errors reported, so that's good. Now, this is a very common mistake. We are not done with grub yet, so I have to go just a little bit more down because we need to generate the grub CFG file, which is just this right here. So grub make config -o boot grub.cfg. Let me make sure everything was spelled correctly. Okay, and then we'll hit enter. OS prober you don't need to worry about, so that warning is meaningless. That's normally if you want to do dual boot, which we don't want to do on a virtual machine. And we're done. So you could edit the grub file. If you watched my OS video, you saw that Ghost of Tsushima or that arcade cabinet boot screen. You could do that in here, but that's kind of outside of the scope of this video. So we're done with grub. So I'm going to go back 3 times. This is the installation page. So that was actually the last step. So what we could do is we could reboot, but we don't want to do that purely because we're in VirtualBox, so it's going to do a lot of weird stuff. So I'm going to hit exit, and then, so I just exited out of the actual machine and I'm back onto the CD, and I'm going to do shutdown -H now. You could just go straight up here and power it off, but this is the way I like to just shut down anything. So I'm going to hit enter. Okay, so what we need to do now is we have to right click on the machine we just made, go to settings, go to storage, and then we want to right click on this and remove attachment, and then hit remove at the pop-up. So now we just took the CD out of the disk drive basically. So I'm going to hit OK, and hopefully what will happen is that I'm going to double click on this to start it. I'm going to do Control F to full screen it. Then I'm going to click inside. Okay, this is already a good sign. I'm going to hit enter here. So our OS is running for the first time on the actual hard drive of VirtualBox. Now, we did not create any users yet. So what we want to do is type in root, because that's the admin or the root user. And we're going to hit enter. And then we're going to type in the password that we made for root. Okay, we are officially, we've just officially installed Linux onto this VirtualBox with Arch Linux. So we don't have any way to technically verify that right now. So I'm going to do 2 things right now. The first is I'm going to try to run pacman. And what we're going to install is something called neofetch. This isn't the best way to do this, but it's the easiest way. Now, I think when I hit enter, I'm going to get an error. So let's see if that's the case. Okay, we got a whole bunch of errors. The reason for that is we have not set up the internet this second time. So it automatically works when you're in the ISO, but it doesn't work when you've installed it for the first time, and that's because we have not activated Network Manager. Remember, we downloaded Network Manager when we did Packstrap. So the way you do that is, let's go to the actual docs. I'm going to go all the way back up to the beginning because we did our internet towards the beginning. And we're going to do, what we technically need is this MNCLI, but I don't know if it's going to work right out of the box. No, so I'm going to go back, go all the way down, and then go to this post installation recommendations. I'm going to full screen. I'm going to go down to networking. And let's try doing this network configuration. We're going to go to network management. Maybe we're not. Oh, yes. Okay. Remember, we downloaded Network Manager, so I'm going to click on that. Okay. We've already installed Network Manager, so we don't need to worry about that. But what we need to do is we have to enable Network Manager. So after installation, you should start or enable Network Manager service. Notice that N and M are capitalized. So how do we enable something? Well, we use Arch Linux uses something called systemd. So the way we start something with systemd, a service, so anytime you see these .service files, you have to use systemd. So that's systemctl start, and then the name of the service. So the name of the service is Network Manager. So let's go here. And I recognize that the text is small again, so I'm going to do set font 122B. Oh, I might have not installed the correct thing, but that's fine. I'll just full screen it. Hopefully this text is big enough. If not, I'll make sure to put this command into the prompt or the description box, sorry. So what we're going to do is click in here first, systemctl start, and then capital N network, capital M manager.service. Give it a few seconds to load. I'm gonna unfull screen this right now. Sometimes when running these services, they don't do it super quick. That's because systemd is sometimes kind of slow, but I think that just was a hiccup. But now we should have internet, so let's do that. Ping. I'm going to do -c4 archlinux.org. Okay, so as you can see, the internet is running. It is being kind of slow, and I think it's because Network Manager is just starting to run and boot up. But that -c4 just means run this command twice. So I'm going to do pacman again, which you can hit the up arrow key to go to stuff we've done before. So pacman-syu neofetch, hit enter again because we do want to install it, and then I'm going to type in neofetch. Fantastic. So as you can see, we are running Arch Linux x86-64 inside the host of a VirtualBox. We're running kernel 6.10.10, the Arch one. We've been up for 5 minutes. We have 173 packages. We're currently running on 218 megabytes of RAM. It is correctly identified my CPU as an AMD Ryzen 9 5900, and my GPU it is not recognizing because you have to do something called a GPU pass-through on VirtualBox. I have an NVIDIA RTX 3070, I think, which we could check. Just to show you that it is different on my computer. So if I do neofetch on my computer, yeah, 3070. I also have the AMD graphics from the CPU, but again, you have to do a GPU pass-through inside VirtualBox, which I don't want to set up. But pretty cool. So we have now officially installed Arch Linux. I'm going to end the video here, and we're going to do configuration in a second video since this video has kind of been a little long. Thank you all for watching. If you have any questions, make sure to pop them in the Discord, and have a nice day.